Good afternoon, this is Schweitzer, and this is a little video on types of collisions. Now, when you have types of collisions, we have one object, let's say a car, and that car is traveling down the road, and let's say this car, I see this all the time, maybe someone's texting or someone is not paying attention, and keep in mind you're driving, let's say, as much as a 1,500 kilogram car, and there's another car in front of you. Let's say you're traveling velocity, let's say you're going 20 meters per second, and let's say the car in front of you happens to slow down or isn't going as fast as you think they're going, and their car, let's say, is say 2,000 kilograms. Hard to see that. So 1,500 kilograms, and let's go 2,000 kilograms. Let's say this car is only going 15 meters per second. So the car behind them will run into the back and collide. Okay. We have a couple options. They could literally bounce off each other with no deformation of the cars. Just you got lucky, you bumped into bumpers, and after we're done here, the let's go C1 and C2. C1 is now traveling at a new speed, and C2 is now going a new speed. Okay, this guy still weighs 1,500. This guy still weighs 2,000, but now the velocity of C1 is lower, and the velocity of C2 is now going to be faster. Okay, so that's one option. We call this an elastic collision. Now, sometimes I refer to this as a bounce. Okay, but keep in mind, essentially, a better way to say this is this is no loss of energy. Okay, now if this car were to, bounce it off, okay, rather than bouncing, hits this car, maybe much more forcefully, and this thing collides and crunches into the back of this car. There's the wheel, and then here's the second car, and they both kind of just continue on for a moment. This is another type of car, a collision here. Okay, this would be called an inelastic collision, where some energy, okay, is exiting the system in the form of bending metal, sound, heat, all sorts of ways. That energy, therefore, is not retrievable and cannot be reused in terms of the crash. You could, I guess, theoretically collect it in other ways, but it's not being used in the crash. So this is not involved, okay, in kinetic energy. Okay, so we call this an inelastic collision. Now again, if they actually stick together and form one lump, we might call this a perfectly inelastic. If it were to bounce, deform, crunch, and then separate, we might have it some version of an inelastic collision. Okay. Now, if we look at how this relates to momentum, we might say that car 1 has some amount of energy. Okay, so it's 1,500 pounds traveling at, let's say, V1, which was 15 meters per second. And then we have, at this point, C1. C2 is going to be another option here, okay. And we have 2,000 traveling at 20 meters per second. Okay? In every collision, the amount of momentum before equals the momentum afterwards. So in this case, the momentum 1 before equals the momentum 2 after. This would represent number 1, and then afterwards would represent number 2. So regardless of the type of collision, we would have the same, this concept would hold true. Now if it is inelastic, then some amount of energy is going to go into this. Okay, and if energy is lost, then momentum still conserved. We might want to take a look at this in terms of energy as well. So in this case, let's say the two cars collide and then just stick together. Okay, so now we have one lump. Okay, so I'll just do a quick little example of this, and then that will be the end of this video. We'll move on to different types of problems, but want to just introduce this idea of conservation of momentum. So momentum 1 versus momentum 2. Momentum 1, we have basically we have C1 and we have C2 equals the momentum of C1 and C2. So afterwards, okay, so in this case we have the mass of the car times its velocity plus the mass of the car times its velocity will equal the mass of the car times the velocity plus the mass of the car times the velocity. Now it's unique in this situation because of how the problem's set up that in the end these guys both have the same velocity. This guy would be velocity f, we'll say. So you could add these together, factor out the velocity f and solve for it. So in this case it would be we have, you could rewrite this mathematically, Vf equals Vf and then mass of the first car plus the mass of the second car, and you can divide out and solve for it. Of course, these are all numbers we have. And let's start putting in our numbers. Either way, I have at this point the mass of car 1 is 1500. Velocity car 1 was 20. The mass of car 2 was 2000. The velocity of car 2 was 15 equals the Vf, which I want to find, and then mass of car 1 and car 2 are both the same, so our total mass is going to be 3500, and I would divide out. I could do this math right here, and then I'm going to let you do that on your own. I don't have a calculator on my hand right now. This looks like about 30,000. May be very similar. Alright, you can solve it on your own, and then you now have your Vf. So this is an example of an inelastic collision. Thank you very much.